Hello guys, it's Marco Schwarz here, and in this video I will show you how to build your own mobile robot that you will be able to control via Wi-Fi using the ESP8266 Wi-Fi chip. So I will show you how to assemble the robot. I will show you how to configure it so we can accept commands via Wi-Fi, and finally we will see how to control it and make it move around using a very nice interface that runs in your web browser. So let's start the project. So let's first see what we need to assemble this robot. So as you can see on the picture, I put the main component of the robot here, which is the Adafruit mini robot rover chassis, which we will use to assemble a robot. This will really be the base. It's a very convenient component because it basically comes with most of the components you see on this picture. So as you can see, there is the chassis itself, but then you also have this wheel here, you have two servo motors and the big wheels here. So that all comes with this component, so it's really convenient to assemble a robot. The only thing I placed on this robot here is this component, which is an Adafruit Featherwind double component. What you can do with it is basically connect two feather boards, we'll see that in a moment, and it really gives us a very nice way to assemble additional boards on the robot. And this is just connected with a piece of tape to the robot base here. So apart from that, you will need some components, of course, to control the robot. One of those components is the ESP8266 chip, which is here on an Adafruit feather board. So we'll just put it here. So you will need this board here. It's a very neat board that I reviewed in another video that you can use for all your ESP8266 based projects. It's very easy to configure. And here we have a very nice way to actually assemble it on the robot. I will show you that in a moment. Then to control the motors, there is also a Featherwind board, which is here. So this is a DC motor and servo board that we will use to control our two servo motors here. So of course this will also be really easy to mount on this double board here. So now I will show you the rest of the components. To power the chip, we'll use this lithium battery here that will power the ESP chip and also the motor board. But you need a separate separate source of power for the motor themselves. So for that I will simply use a pack of AA batteries here. So there are four 1.2 volt batteries, so that's nearly 5 volts of power to power those two servo motors. So that's all the components you will need for this project. Okay, so I will now show you how to actually assemble the robot. The first thing I will mount on this robot is the shield for the motors. So I will just mount it here. And you can see it's quite easy to assemble on the other feather board. And now I can actually already connect my motors. So I will just connect them on these connectors on the left here. I will secure them later. So just like this, and you already have the motors connected to the robot. So now I will actually take care first of the power. So as you can see, I mounted those batteries here on this additional component that will later come as a second stage of the robot. But first I want to connect this power to the robot. So I will first take care of the positive power supply here. So we'll just insert here and secure this connection here. Then I will take care of the ground. As you can see, the shield is already lighting up. And I will secure this connection here. Perfect. So now I have the power going to the motor shield. I will just leave it like this here because I will put it on top of the robot later. And now I can actually place my ESP8266 board on top of this robot. So I will just put it right here. That will do it. So now I have my two boards on top of the robot, so I can actually now mount this stage here on top of the robot. So just put it here, and I will now attach it with the first screw, just right here. There we go. And now we'll just make sure it actually stays here by placing a second screw. And here we go, I have my second stage mounted on the robot with the batteries. So now the last step is to actually place the battery that will power the ESP chip itself. So the battery is right here. I just placed a little piece of tape under the battery. And now first thing is I will connect it to my robot here. And finally, just place this battery here on top of the robot, just like this here, and hold it with some tape. Of course, you can find more elegant way to hold it, for example, using screws, but for now, for this tutorial, I will just hold it with some tape here. So that's now your robot fully assembled, and we are ready to configure it. So we are now going to see how to actually configure the robot so we can accept commands via Wi-Fi. So this is the Arduino sketch that we will use for that. So you will find, of course, all the details inside the corresponding article on my website. But let's see the main point here. So we will use the ARS library that will allow us to easily control the robot via Wi-Fi. Then we define everything concerning the motor here, so we can control them using the Adafruit Motor Shield library. Here, that's the only thing you need to modify inside this code is your Wi-Fi name and password here. And then you can see that we create those functions: stop, forward, right, left, and backward, which are the basic functions to control the robot. After that, we expose those functions to the ARS library so we can control them via Wi-Fi. And to finish that, just have a look at one of those functions. So pull forward. As you can see, it puts the speed to nearly the maximum on the left motor and the right motor in the same direction, which means that the robot will go forward. And just as an example, the left function will be at a reduced speed, but one motor is going backward and one motor is going forward. So before you can compile the sketch, make sure you have the libraries installed for ARS and the Adafruit Motor Shield. Also make sure that you install the board definitions for the ESP chip. You will find all the details inside the article on my website for that. And now go to Tools, choose the board that you have. Here is an Adafruit ESP8266 board, and also select the right port. So here, this port USB to UART for my robot here. So last thing, as you can see on the robot here, I just put some one breadboard and some bugs that I found on my desk, just to make sure that for this test, the robot doesn't touch your desk here. So as you can see, there is some space below the wheels. This will make sure that when we test the robot, it just doesn't run off your desk and actually you might damage it later. So make sure that for now the wheels are not touching the desk or the ground. After that, we can now configure the robot. So make sure you have the serial monitor opened here, and then simply upload the code to your robot. So it will compile the code and then it will upload it to the Adafruit board. You might not see it on the video, but the board is currently blinking, meaning it's been configured by the sketch we just saw here. So now that's done, so the robot is configured, and what you can see in the serial monitor is the IP address of the board, and you will need that in a moment inside the interface, so make sure you have these values in mind. So I will close this now and go to my favorite text editor to open these files here that are in the interface folder inside the GitHub repository of the project. So you can find all these links inside the article on my website as well. So as you can see, we will basically make a simple interface to control the robot remotely. So we'll have some buttons like forward, left, right, and backward to control the robot. And inside the script .js file, you need to enter the address of the robot here. So as you can see, this matches what I got from the robot before. And after that, we basically link each of the buttons to an action on the robot. So for example, the forward button, when we press with the mouse on the forward button, it will call the forward function. But when we leave this button, it will just stop the robot. So this will really make the buttons behave like push buttons that make an action when you press on it, but stop this action when you release the button. So we are now ready to test actually the robot. So I will just close this here. I will save it and close it. And I will go back to the interface that I already loaded somewhere. So I have my very simple interface here. And I will just try it out. So for example, if I want to make the robot go forward, I will just hold the forward button. And as you can see, the robot is going forward. And when I release, it will just release the command and actually call the stop command on the robot, which will stop it. I can try the other function now, like backward, right, and left. So as you can see, it's a very convenient way to control the robot. It reacts nearly instantly thanks to the speed of the ESP8266 chip. I will do it again, forward, left, right, and backward. So finally, let's see how the robot is actually behaving in the field. So now, as you can see on the picture, I plugged again the battery to the robot, so it's completely autonomous and still connected to my Wi-Fi network and ready to accept commands. So I will just try it out here. I will make it go forward, turn left, forward again, turn right, forward, backward. As you can see, even without being connected to my computer, it's very reactive. It reacts instantly to the command thanks to the iOS API. And I should just make it again, forward, go left, forward, and then backward. So this is already the end of this video. I hope that you enjoyed it. So in this video you learned how to build your own mobile robot based on the ESP8266 Wi-Fi chip. So there are of course many ways to improve what you learned in this video. For example, a very easy thing to add would be to add a distance sensor in front of the robot and also have it displayed inside the interface so you can know what's in front of the robot. So as usual, if you have any questions or comments, please use the comment below this video. If you need more information about how to build this robot, please visit the article on my website at openhomeautomation.net. You will find the link also in the description of this video. Thank you again for watching, and I will see you in the next video.